So now we're going to look at completing the square, because it's not always possible to factorize a trinomial. So completing the square means that we're rewriting the expression in the form x plus p all squared plus q, where p is half the coefficient of x and q equals the constant term, take away the value that we've just worked out and squaring it. So the constant term, take away p squared. So let's have a look at an example and figure out why this is the case. So we're going to express in the form x plus p all squared plus q the trinomial x squared plus 8x take away 1. Now, we've said that the p value is half the coefficient of the 8x, so it's just the number. So don't be tempted to keep the x with that number. So we've got open brackets x, half of plus 8 is plus 4, and that's all squared. Now we want to bring down that negative 1, and we want to take away that p value that we've just created squared. Now, why do we want to do that? Well, if you think about squaring that x plus 4 squared bracket, if we use our quick method, we're squaring the first term, that's x squared. We're doing twice the product, so x times 4 is 4x, doubled is 8x. And then we're squaring the final term. Now, we want a negative 1 as our term at the end, but we've got a plus 16 when we expand this bracket. So we need to take away that 16 in order to be able to expand and simplify to get back to where we started. So it means that our final answer is going to be x plus 4 squared, take away 1, take away 16. And that gives us a final answer of x plus 4 all squared, and negative 1 take away 16 gives us negative 17. Now this skill is really important when we come to do our parabolas, because it will help us determine what our line of symmetry is and what our turning point is. So let's have a look at another example. This time we've got x squared minus 4x plus 7. So again, we want to half the coefficient of the x term to give us our value for p. So half of negative 4 gives us negative 2. So our bracket is going to be x minus 2 all squared. And do remember to put the squared on your bracket, otherwise you'll lose the mark for determining your p value. Now we need to work out what q is. So we're going to bring down that plus 7, and we're going to take away the p value, which is negative 2 all squared. Now, don't be tempted to think that negative 2 squared is negative 4, because it's not. Remember, a negative times a negative gives you a positive answer. So we're going to end up with x minus 2 all squared, and that's going to be plus 7 take away 4. And that gives us a final answer of x minus 2 all squared plus 3. Now, if you're not sure whether or not you've got the right values, there's nothing to say that you can't do your expanding and work backwards to do a check. So I'm going to do a check over here, and I'm going to expand my x minus 2 all squared plus 3. So I know that that's going to give me x squared minus 2x doubled is minus 4x plus 4 plus 3. And when I gather my like terms together, I've got x squared minus 4x plus 7, which gives me what I started with. So the final example, I'm going to express in the form x plus p all squared plus q, x squared minus 7x minus 4. Now, I've got an odd number as my coefficient of x, so it means that I'm going to be working with a decimal or a fraction in order to get my q value. But that's absolutely fine. So you can write it as a decimal, or you can write it as a fraction, it doesn't really matter. So we need to write our bracket. We've got an x. Half of -7 is -3.5. And that's all squared. And then we're going to take away 4, and we're going to take away -3.5 all squared. Now 3.5 squared or -3.5 squared is 12.25. So the next line of our working out is going to be x minus 3.5 squared. I'm going to take away 4, and then we're going to take away 12.25. And so our final answer is going to be x minus 3.5 squared, and minus 4 minus 12.25 is minus 16.25. Now, as I said, you could write it as a fraction. So you could have x take away 7/2 all squared, and that would be take away -65/4. So either write it as a decimal or write it as a fraction.